I'm Pat Warner, and this is my shop and garage here in Escondido, California. Some of my friends think of me as a slightly unconventional woodworker, but I don't think I'm so unusual. I've got a bandsaw, planer, joiner, and 20 routers. I make part of my living inventing router accessories, but before I did that, when I was teaching myself to work with wood, I learned that if I used routers with jigs, I could get to a level of precision in cutting joinery that I just didn't know how at the time to get with other tools. I got a friend who thinks I'm crazy about precision for its own sake, but the truth is I'm motivated far more by laziness than by an obsession for accuracy. Careful work up front translates into easy assembly, less guesswork as the project proceeds, and more time in my hammock. There are two species of routers: fixed base, which just sit there and route, and plunge routers, which move up and down over their bases. In most important ways, their anatomy is the same. Let's get going by analyzing a fixed base router. Any fixed base router is basically a motor and a router base, which holds the motor pack and lets you grasp and manipulate the whole affair. Except for horsepower, motors vary in only a few ways that matter to the user. One way is how they engage the base casting and how they change their position in the base. There are four basic mechanisms. The Bosch 1617 motor pack is steered into its base on a pin that follows this slot. The rough height adjustment is made by the end of this lever that engages one of the three rectangular notches. The fine adjust on the Bosch is driven by a screw. The Porter Cable 690 motor barrel has four pins which engage two helixes machined into the base casting. With a twist, this motor raises or lowers. The Milwaukee's motor gets dropped into its base casting and hangs on the threaded plastic ring. A twist of the ring changes the motor height. And the DeWalt 610 has a rack on its motor pack that's grabbed by a pinion gear in the base. A twist of the gear here changes the motor height. Let's take a quick look at how the switches can vary. The yellow DeWalt has a toggle switch that's always in the same place with respect to the grip handles on its base casting. It's protected somewhat from an accidental start by a hood, which is part of the casting. The Bosch tool has a reasonably well protected rocker switch with international on and off symbols. It functions well, but I'm not always sure of its position when I'm plugging it in a few feet away. This motor can be installed in its base in two different positions, 180 degrees apart, so the switch can be in two different positions. That can be good for lefties. The Milwaukee slider switch is big and unlikely to get accidentally switched. Its position is not clear at a distance, and it's always in the same place with respect to the base grips. All base castings are similar. The Bosch comes with genuine wooden control knobs, but they don't really work any better than plastic. Bosch happens to be the only manufacturer to use magnesium, which means substantial weight savings. Bosch also has a plastic chip deflector in some of their machines, which is good because the chips will go out the rear window, not the one you're looking through. Most of these inspection windows, which let you see what you're cutting when the router's on, are all about the same. Cheap wing nuts are the typical motor locking hardware. No one really likes them, and that includes me. They're just too hard to tighten them. There's just not enough leverage. Whenever I can, I scrap mine for a lever assembly, which you can get from a number of sources noted at the end of this video. The Bosch Quick Action Toggle Clamp is the best of the lot. All you need to do is latch it, and it tightens the same amount every time. The base plate is a necessity that goes under the base casting. You need one of these because the bottom of the base casting is not a solid, smooth surface, and it will snag on the corners of your work. Black Bakelite is the typical material. The Porter Cable has a transparent offset sub-base accessory. Now that's a good way to keep the tool flat and not tippy under most conditions. This sub-base gives a very good grip, which is no small matter with a hand router. The collet is a thing that holds a bit, or cutter as I call it, in the motor. It's a steel sleeve that's partially slit through from top to bottom so that it can compress when it's squeezed by the collet nut, which tightens down around it. Most collets today come snapped into their collet nuts, so when you loosen them, they pull themselves right off the cutter without sticking. 1/4 and 1/2 inch collets are the common sizes. The routers we've been looking at use 2 wrenches to tighten the bit. The general rule about inserting cutters is get all the shank in that you can, and for a long shank, instead of bottoming out the cutter, lift it up about a 1/16. Use about 15 pounds of squeeze to clamp the tool. And for more leverage, finish off the tightening with 2 wrenches in one hand. The collar guide is a handy way to control the pathway of the router. It always works with a template. The Porter Cable 2-piece collar and nut is the most common because other manufacturers happen to have adapted it. The collar is always bigger than the cutter inside of it, so you need to account for that when you design a template. You'll frequently have to shorten the length of a new collar guide, but more about all of this in the segment about collar guides later in the video. The edge guide is another tool for controlling the router's path. All routers are designed to use one of these. This is usually a pair of rods and a cast body that slides on them. Screws in the casting hold the rods. The edge guide slides along the edge of the work and steers the router in a straight line. And just a few words on power cords. Most are rubber jacketed, which is much better than a plastic on cheaper tools. Some are 3-wire, but if the tool is double insulated, then they're 2-wire. The Sears extension cord has a lock in the socket end and a light to indicate that the power is on. A real thrill of a wire. A $10 straight bit is the most valuable of cutters. This is the most common and the cheapest of all bit designs, but they're capable of nearly any cut that has straight sides. When you make a circle, a hole is your byproduct, and when you make a hole, a circle is your byproduct. So do you make a circle and a hole in the same way? Not exactly. But before you try to make either with a router, you need to make a template. A hole template for routing holes and a circle template for routing circles. Now here's my simple jig for making circle or hole templates. It's just a maple router base that pivots on a 1/4 inch pin that you set into a 1/4 inch hole you've drilled into your template stock. Now that pin is held in a sliding arm that allows you to set the precise radius you need. A plunger is the tool of choice because you'll want to cut down in stages. Spin the whole affair 360 degrees to make sure you can do it. My template stock is MDF. I like the material because it wears so uniformly and because of its dimensional stability. The DeWalt tool has its own vacuum port for cleanup. My trusty assistant now will manage the hose for me. Set the depth of cut for a little less than half the thickness and cut from both sides in a few stages. When your cut puts the entire diameter of the bit into the stock, you should use solid carbide. If you only need one template for a circle and not a hole, let the cutter pop through the edge for inspection. If you do this correctly, you should be leaving a thin uncut web of the disc which will continue to hold it in the blank. Cutting entirely through it would cause the disc to slam against the cutter when it frees itself and just spoil everything. Next, break the disc out of the blank. You can trim the flash away with a little trim bit. This is a $5 throwaway bit. When it wears out, throw it away, but hang on to the bearing. The disc is now a template. Mark its circumference on your workpiece and bandsaw the waste away. You can use a bearing or washer to translate the saw cut line away from the template a little bit. Now bandsaw on the inside of this line. Now we have a good disc and a useless wooden ring. Clamp your template to your rough disc. The cameraman seems to be interested here in this welded tab that holds my big C-clamp permanently to my bench. But let's get on with it. Now you just trim the remaining waste away with a shank bearing flush trim bit. A new cutter, newly machined template, and a little skill and you'll make great discs. Could be that we have a lamp base or a small tabletop here. The process is very much the same if you need a hole. Only here, a drill and a jigsaw will give you your rough hole. Drill an access hole for the saw blade and jig out the dead disc. Clamp the disc to the template and zing away the waste with a trimmer. No better way for making speaker boxes. You use a collar guide to control the pathway of the cutter, and it always works together with a template. The collar slides against the template and, of course, guides the cutter along the same curve. There are three main types of collar guides in circulation these days. One is the Milwaukee. You simply screw it onto the Milwaukee subbase. The Porter cable collar guide is a two-piece screw and nut affair that fastens together from both sides of the subbase. This accessory offset subbase I'm connecting it to will give you better control, especially when you run out of the supporting surface for your router on tight corners. The Bosch bayonet system uses a spring-loaded holder fastened with screws to the subbase. The variously sized collars snap in and out. The distance from the cutter to the outside of the ring is what we call the offset. The offset is equal to the ring diameter minus the cutter diameter, and divide that by 2, 3/8 in this case. Here's a rough edged board with a straight edged piece of MDF clamped on top of it as a template. The template is offset by 3/8 of an inch plus a 32nd or so. Clearly the cutter will always be smaller than the collar. Here you can really see what the offset in the collar and template is all about. I start with a light climb cut just to get the feel for the situation. I've set the cutter depth to extend just below the work. That offset subbase lets me keep a good grip on the overhung router, especially at the ends of the work. I finish up the cut moving left to right. Now before I remove the template, I measure the actual offset. This is the empirical way to know the real difference between the cutter and the collar radii, and it's much more accurate than holding a ruler up to the tool before you make the cut. I record that number so that I know exactly where to position the template next time I use this collar and bit combination. This collar ring will follow any curve whose inside radius is larger than the ring itself. It doesn't matter what the outside radius is. Now when you're using a collar guide, there's something that's not quite intuitive that you should keep in mind. The collar is never exactly concentric with a bit. So if the point where the collar bears against the template changes during your cut, you may not get consistent results. If you watch that little mark I've made on the collar at the bearing point, you can see that I rotate the router slightly as I come around the curve to keep just that one point in contact. All collars need to be shorter than their templates are thick, otherwise they'll just bump into the work. But collars come in many different sizes, and the one you have may not be right for your template thickness. We'll cut this one in a subbase. I put the base in a vise and screw the guide together. I'm using a plastic guide shield for the hacksaw. I made this little holder for grinding. Just lightly brush the collar up against the center and smooth it out. After that, I'll deburr it. This is a neat and an inexpensive little machinist tool that just scrapes away the burr. But you can use wet or dry 220 silicon carbide paper just as well. You can feed work to the router table on edge or face down on the table. The cut's the same, but it expresses itself differently. In a way, that doubles the usefulness of most cutters, and that fact may save you a nickel on your next cutter purchase. This OG cut was made with the work on edge with its face against the fence. This cut is done in the conventional way with the work flat on the table. The same cut, but a substantially different look. OG cutters eat a lot of wood, so you should cut in stages out of respect for the equipment and for safety. Here's the cut on edge, which would not be safe if the work were too narrow. I'd handle a stick 3-inch wide or wider. Otherwise, I use fixtures to hold the work, or I mold the edge on an over-width piece and then rip down the final width on the table saw. Although the video has compressed the time factor here, all of these cuts, face and edge, were done in less than a minute total. With a handheld router and some simple jigging, you can end lap any pair of sticks. They don't even have to be the same thickness or width. Laps are shallow cuts and easy to route. To start, hold the work flush to the end of its mate and scribe a knife line. Not much there, but just enough to see so you can reference the jig. This is my jig upside down. The fence is perpendicular to the work edge of the window template. In goes the first of 2 pieces to be lap joined. The screw with the black knob sticking out on the right will let me locate the scribe line right at the edge of the window. One clamp is not enough. The cutter's forces on the work can dislodge it as you work from side to side. The cutter of choice is a short-fluted, shank-bearing trimmer. The bearing will roll on the window's edge when I make my final pass to establish the shoulder. This edge must be straight and free of defects. It will telegraph any blip right into the work. If you're lapping sticks of equal thickness, you want to measure and calculate the half thickness. A shortcut I like to use is a transfer punch with a diameter equal to the half thickness to set the final depth of cut on the plunger. I scrapped the depth turret on this tool to facilitate this kind of adjustment. This is a dirty job. A half the thickness of the stick is going to be turned into dust. A vacuum attachment will keep the chips out of my face anyway. This screw is so tight it'll never move by itself, but the wing nut's spinning out, so I'll tighten it now and get on with the process. It's never a smart move, however, to make any adjustment when a tool's running. First, waste a little stock around the perimeter in a climb cut. This will prevent edge tear out caused by the bottom of the cutter at the visible edges of the joint. I've attached a larger subbase to keep the router from dipping into the window. Don't sand too much around a lap. You can quickly spoil the interface fit. Just brush the surface tear out off. There's no need to mark the next stick. Just index it to the screw and clamp it in place. Not a perfect fit, but not a bad try. Now, let's try an arbitrary cross lap. These sticks won't be the same thickness or the same width. We use the cross stick itself as a map template. Put it anywhere you want it and map out its position with 2 3/8 thick MDF straight edges. 2 clamps would be better for each template. You could bump one of them and spoil everything. Remove the stick and start the route. The shank bearing must roll on the edge of the MDF. We'll be cutting down in 2 passes. First, waste a little on each edge to prevent tear out and breakout. Breakout would certainly occur if we were to plunge into the middle first and route out toward the edges. Some tear out at 2 of the corners is inevitable, but if I climb cut a little into each corner before the bearing rolls along the template edge on its final pass, I'll prevent most of it. Here you'll see a little tear out where the clockwise spinning cutter exits the corner. And here there's none because the cutter enters the corner and the wood is backed up. Inspect the edge of the excavation before removing the templates. If you've missed a spot, you'll never get the templates back exactly right. Get whatever surface tear out there is to make sure nothing interferes with the fit. Close fit. Now we'll lap the mate using the same technique as before. This is some scrap to support the MDF templates. Lower the bit so it just brushes the work and lock the motor. I haven't talked about the depths of these cuts yet. Let's say here's the first piece we cut. It looks like we've notched out about half its depth, but that's completely arbitrary. Here's the cross piece that will lap into the first one. At what depth do we cut this piece so that it will be flush right here? That's easy. It's this depth, which is the difference between the thickness of this piece and the depth of the notch in the first piece. That little bit of tear out I think we can take care of when I sand. A good exercise in low-tech, high-precision work. It's a swell way to join frame parts and a great way to add reinforcement to under-designed frames that are already assembled. That's my dog Chewy, and that's my router table. I love them both, and I'd sure miss either of them if they weren't in my shop. I built the router table I use, but they don't have to be this elaborate. A 2 or 3 foot square flat surface clamped to the workbench like my friend Gary Rogowski uses might be all you need. I prefer the conveniences I built into this one, and you might like some of them too. The top is a 2 foot square piece of MDF soaked in Danish oil. Router table work is demanding, so you should use the biggest motor you can afford. This one is a 3¼ horsepower Porter cable, and the casting is securely attached with 5/16 machine screws. I changed the wing nut motor clamp with an easy-to-grip lever. The levering action of this one secures it a lot easier and quicker. The box is hardwired. A simple wire winder underneath keeps the cord neat. The motor and vacuum plug into a double socket on the inside, and it's controlled by a single switch buried in the mortise of the exterior. It's pretty handy and buried deep enough so you can't accidentally bump it on. It's a lot safer than groping for a switch under the table. A strategically placed pin used as a pivot on the tabletop will give you some control of your work, but using it for a full-length cut can be tricky. The safe way is to brace the work against the pin and begin the route at the end of the stick. Pivot it away after you have control. The pivot in this case is a little 1/4-inch arbor that threads into the MDF. The pivot fulcrum pin can be used at the end of the stick if you want, but you can't route the first few inches safely if you do. The work jumps violently if you don't have some leverage to hold it. The real key to routing efficiency, chip collection, and control on the router table, though, is the fence. You can use a simple stick, but a little MDF with a vacuum funnel is better, and a fully adjustable model like this one is actually really fun to use. For real control when you're doing straight line work on the router table, use a fence. This plain one pivots at one end for easy adjustment. It's just an 1 3/4 square stick with a notch sawn from the middle to accommodate the unused diameter of the cutter. The arrow shows the safe direction to feed the work. Clamp the free end after you've adjusted the cutter exposure you need. The fence controls your depth of cut, so remove the bearings on your cutter. They still spin even if they're idling, and that counts against their lifetime, which is only a few hours at most. This MDF fence isn't bad for edge work, but make it at least 5 inches wide so it won't bend. The vacuum funnel was borrowed off another router, and it's held in place with a couple of screws. This type of fence is just clamped to the tabletop. Make sure it's secure though. You need to apply a lot of pressure to hold the piece you're cutting against it. When I work on a router table, I have a habit of applying the force against the fence beyond the cutter. A slip out here means nothing. An accidental slip with the force being applied in front of the cutter could be bloody. From the simple to the simply terrific, this fully adjustable fence actually makes the process enjoyable. Of course, I'm partial because I designed it. There are 2 sections for adjustments, micro and macro, and the fence halves even slide left and right down to a 1-inch gap to minimize cutter exposure. Short end cuts should never be made on the table without a holder or a backup stick. The end of the work against the fence or the top always puts you at risk. End cuts are safer when you hand route them while they're being held in a fixture. Save the table for edge and face work. One benefit of the router table is its dust collecting capability. A hand route on MDF can have a lasting effect on the environment. A quick route on the table is dust-free with a good vacuum system. They're not expensive, but you have to think ahead when designing your table. A perfect time to take advantage of a router table and this type of fence is when you need the edge joint function of a joiner. A joiner straightens the edge of a board by planing away its bottom surface as it's pushed from an infeed table set just below the top of the blade's arc onto an outfeed table set at exactly the height of the blades. Turn a joiner 90 degrees and you've still got something you can joint with, but it looks just like our router table with the split fence. I prefer this arrangement on short or wide stock because it gives me a lot more control. Or you can make that pivoted straight stick fence function like a joiner fence on a router table. Dimension it fat enough to resist bending and saw out of V-nuts to contain your straight bit. The height difference between the infeed and outfeed sides of the fence will accomplish with a layer of Formica, which is about 60 thousandths thick. A better choice would be a thin sheet of aluminum, say 15 to 25 thousandths, because the cut will be lighter and less destructive. Contact cement is stripped to the outfeed side of the fence, and I trim it all up with a flush cutting bit in a lightweight router. Now the outfeed side is about a 1/16 higher than the infeed side. The pivot will let me rotate the fence so the Formica side is flush with the cutter. Clamp the other end down. Once you start joining, you'll probably need to adjust this slightly. Here's a piece of oak that could use a jointed edge. Joining makes a lot of chips, so we're vacuuming right at the cutter. The force of your hand should go against the Formica side of the fence to keep the work from rocking. Another time to use this joiner setup is when you need to make a full thickness cut, wasting the entire edge. The offset fence is key to the process. The outfeed side is a 30-second proud of the infeed. First, center the cutter to the work thickness. Then, position the fence until the outfeed is slightly proud of the cutter. The fine-tuning will be done when we start cutting. The first pass wastes the whole edge, but not enough for the outfeed fence to receive it. I'll use the micro adjuster on my fence to move the whole fence 5 thousandths back and take another pass. I'll repeat the process until the work passes gracefully to the outfeed. If both fences are parallel and offset correctly, there's no snipe. Real fun, and the work is jointed and molded in a single pass. By using the carbide bit on the router table, you can also joint MDF, plastic, and other materials that steel joiner blades find objectionable. The fence is set for a 15 thousandths cut. Not much, but 3 or 4 passes add up to a 16th in just a few seconds. Lastly, the table router has an advantage in template work when you're doing a short run like these shelf hangers. Clamping is easy. You can see what you're doing. It's easy to keep the work flat on the table, and cleanup is a cinch if you position your vacuum close to the cutter. It's best to use a holder and pre-trim the work. One thing I've found in my years of router table use is that stooping to change the motor height and cutter is great for you. Everyone should do it 10 or 20 times a day. Use the shortest bearing guided cutter you have for this. Too much cutter exposure presents unnecessary risk. Set the cutter to minimize its extension just above the work. I use the toggles holding the template as handles. It gives me a lot of control and keeps my hands away from the cutter. A straight bit is your best value in a router bit. Its application is enormous and they're cheap. Here we'll use a $10 steel bit in a plunge router with a collar guide to route a mortise. Then we'll drill it out and use a trimmer to make it a through mortise. A plunge router is the best tool to make mortises because you can plunge a little at a time and avoid breaking the cutter. This template, made earlier for another mortise, is proportioned to the collar guide for a 1x2 mortise. I made it with a fence to keep it parallel to the long edge of the mortise window. Make sure the template is securely clamped to the work. Lower the cutter to the work and lock it there. Let's arbitrarily cut this mortise to a depth of 5/8. I'll use this 5/8 long collar as my depth guide. Place the spacer under the depth stop, adjust, and then lock it. This steel bit is ground on its end so it can plunge just like a drill. Make 3 or 4 passes to reach 5/8. Most routing is surprisingly freehand. Look at this chopped up mess. When the collar finally slides against the mortise window, the excavation will take shape. Blind collar mortising will trap some chips, so you'll need to clean this up from time to time. Before undoing the setup, I feel for any uncut areas. If I find an error later, I'll never get the template back in the same place to clean it up. If I'd use some stop blocks with it, though, that wouldn't be much of a problem. There you have it, a perfect mortise. But we're going to make it a through mortise, so let's move over to the drill press and drill out most of the waste. The mortise itself makes it easy to keep the drill in the confines. We didn't go all the way through with the router in order to demonstrate this technique. There may be a time when your router bit just won't make it all the way through. The wood's too thick or the bit's too short. So there is value to this exercise nevertheless. We could have drilled first, but this approach will minimize any drilling errors. The drill press is way undervalued. I probably spend more time drilling than routing. Now, turn the stick over and use a cheap trim cutter to finish the cut. Adjust the cutter so it won't touch the bench. The bearing rolling along the pre-cut mortise will guide the cutter to smooth the edges and finish off the cut. Now you have two choices for the tenon to fit. Round the corners of the tenon or square up the mortise with a chisel. Look how the upper half of the end of this mortise is charred. A sure sign that the trimmer we just used is ready for a regrind. Think of templates as the software for routing. They're encoded with information to transfer their shape to the work. Take this one for example. It can be used in at least 3 ways to produce quite different and striking results. The simplest of cuts is the full thickness route to template cut. A flush trimmer with its bearing rolling on the template cuts the work in its entire thickness to copy the shape of the template. Templates are used for everything, from layout to decoration, and many projects require several different templates to shape curved parts or assist in router joinery. A template for one job may be useful in another. The next cut is a fractional thickness cut. Raise the cutter and waste as before. Hang onto the work and template with at least 2 clamps. If the template slips, you'll ruin the work. Keep the clamps at least 1 router base radius away from the edge of the template. A shank bearing guided tool requires the template on top of the work. The third option uses a collar guide and a straight bit to produce a line cut, somewhat equivalent to a dado, only this one follows the contour of the template. If you lose contact with the edge of the template this time, you'll spoil the cut. The offset base helps here because I can pull the collar against the template as I work the slot. The other 2 cuts were open cuts and not subject to this risk. When you use a collar guide system with a curved template, the result is not an exact copy of the template. The inside radii copy smaller on the work and the outside curves copy larger. Take your time when you're making templates. They should fit your work and leave plenty of room for clamping. These were just experimental cuts to demonstrate an idea, but you'll find most template routing is one of these 3 cuts. Cool. Good shot. Great. The sliding dovetail is an excellent joint for right-angle joinery. There's no need for hardware and the joint doesn't open with shrinkage. Sliding dovetails can be down grain, as in a stile and rail, or across the grain, like the dado for a shelf. The one we'll make would be perfect for a light leg and rail in a bedside table or a door. A dovetail bit is shaped like a triangle, so stage cuts to reach the depth you want for your dovetail pathway aren't possible, and a single pass at this depth would break the cutter. Your best bet is to clear the way first with a straight bit whose diameter won't eclipse the minimum diameter of the dovetail cutter. It's safer to use a router table for the sockets in legs and stiles. Mount your router with the straight bit and extend the cutter to approximate the depth you've set for the pathway. Lock the motor. Now, adjust the fence for the center line. I want the socket length to be equal to the width of the rail, less a quarter or so. Mark its full width and measure back about 1/4 of an inch. That's where I want the cutter to stop. The sweetest way to make the deep plow is to raise the work on a stack of lifts, removing one for each depth of cut change. I use a 3/8 shoulder bolt to trap the lifts and keep them from moving. I used to use clamps, but they always got in the way. Now clamp a stop on the outfeed fence to stop the work about 1/4 inch short of one rail width. Now we'll test the cut for pathway length. You should make all of your preliminary cuts on test pieces to minimize surprises on your final work. I missed, so I'll mark a line on the fence for reference and move the stop accordingly. It's about right now, so let's start and run through the lifts. I've made the stop narrow so chips won't collect under it and block the work from reaching it. Do your best to keep the work in a straight line. The deeper the cutter, the more important this is. You could break the cutter if your feed is sloppy. You can route safely to 1 inch or so in 1/2 a minute. If you've held onto the work and everything is square, you'll leave no cutter overlap on the wall of the mortise. Now, change cutters. The only variable is to adjust the depth of the cut. It's a good idea to make it a little deeper than the mortise. Taking a little wood at the end of the bit aids in its tracking. If you're careful and don't move anything, the dovetail path will be right down the center of the straight bit cut. This is still a substantial cut, so hang on to the work. That much racket signifies cutter overload, but there ain't much you can do about it. To be sure, dovetail bits are inherently weak and they push the limits of strength possible in a bit. For my first attempt at determining the length of the dovetail, I'll scribe a line based on the depth of the socket. Now I'll use a jig, which is just a square corner, a template, a sliding right angle that can be clamped to that corner, and a collar guide to make the cuts, one on each side of the work. The template is clamped to the top to prevent it from moving under the load of the router. The work is clamped twice and positioned or indexed under the template. My rough red scribe line will be my first guess at the depth of cut. Test this on scrap first. A big router for a big cut. It may not seem like much, but there's a lot of waste for this much cutter extension. This is the same size bit we used for the mortise. I don't recommend trying this climb cut here unless you have some experience at it. If you're a beginner, get your feet wet with light cuts first. The final pass is always anti-climb, against the cutter rotation. Turn the piece 180 degrees and repeat the cut on the opposite face. This is the reason for using sample stock when setting up the cuts. Not only is this tenon overcut and too narrow, it's also too short. Adjust the cutter extension first and move the right angle template closer to the work to thicken the tenon. Instead of a C-clamp, my template is held by a steel bar and a toggle clamp. I use a feeler gauge as my spacer between a reference stick and the template to make the adjustment predictable. If it turns out to be too much or too little, I can use the next size feeler to correct on succeeding attempts. Now, we'll cut a tenon on the opposite end of the sample with the new settings. This one is correct in length, but too wide. A few more iterations will make it right. Got it. Now we can cut the project stock with confidence and not waste good wood. The squared tenon bottoms out in the rounded end of the tunnel, but a third shoulder cut with a round-ended template will get the tenon to completely seat itself. This too is a calibration cut. I'll never hit the shoulder on the first try. The work is in the same fixture, but this time it's clamped 90 degrees to where it was before. My second guess, an acceptable fit. Clamp the template down well. You don't want to lose your place for the rest of this run.